Hello students, welcome to the lecture on Introduction to Oil Business, and after this lecture we will be able to learn the following objectives. Understand the basic concept of petroleum, discuss the constituents and significance of petroleum, explain the characteristic of oil and gas, explain the main products from oil and gas and their uses, discuss the terminologies used with respect to oil and gas. Let's start with the concept of oil business. A very fundamental aspect of equity investing understands the companies and sectors in which one invests. In the equity universe, there are a number of sectors, and equity investors require some specialized knowledge to make educated investment decisions. One of those sectors is the oil and gas sector, which is teeming with complicated terminology that can overwhelm investors new to the space. With a basic understanding of this terminology and the oil and gas business in general, investor can better understand the fundamentals of oil and gas stocks. The oil and gas industry is made up of many players, each of which has a specific job that spans the spectrum from discovery of the fossil fuels to the delivery to the end user. Let us now discuss the basic concept of petroleum. Petroleum or crude oil is a complex, naturally occurring liquid mixture containing mostly hydrocarbons but containing also some compounds of oxygen, nitrogen and sulfur. It is often referred to as the black coal, the Rockefellers, the Rothschilds, the Gettys, the Hammers and the royal families of the Persian Gulf area would certainly agree. A view at Fortune magazine list of billionaires confirms it. The Sultan of the oil-rich Brunei on the island of Borneo has been at the very top for quite some time. Saudi Arabia's King Fahd is up there as well. After World War II, the huge oil reserve in the Middle East became available at a very low cost, and they rapidly revolutionized the way we lived. Petroleum formation. Petroleum forms by the breaking down of the large molecules of fats, oils and waxes that contributed to the formation of kerosene. This process began millions of years ago when small marine organisms abundant in the seas. As marine life died, it settled at the sea bottom and became buried in layers of clay, silt and sand. The gradual decay by the effect of heat and pressure resulted in the formation of hundreds of compounds. Because petroleum is a fluid, it is able to migrate through the earth as it forms. To form large economically recoverable amounts of oil underground, two things are needed: an oil pool and an oil trap. An oil pool, which is the underground reservoir of oil, may literally be or it could be droplets of oil collected in a highly porous rock such as sandstone. Properties of petroleum. The elemental composition of petroleum is much less variable than that of coal, 83 to 87%, carbon 11 to 16%, hydrogen 0 to 4%, oxygen plus nitrogen and 0 to 4% sulfur. Note that most crude oils contain substantially more hydrogen than coals. Only a brief discussion is needed here regarding the distribution of these elements among the thousands of compounds found in petroleum. Most of the compounds in petroleum contain from 5 to about 20 carbon atoms. The ones that have a low molecular weight are volatile. For example, they easily evaporate from gasoline at filling station. Many among them are carcinogenic. Crude oils can be classified in a number of ways. Consider first a crude oil that is in the very early stages of being produced from kerosene. Long chain compounds in the kerosene will not have broken apart to a great extent because the oil or kerosene has not yet been buried very deeply, so it has not been exposed to high temperatures in the earth, nor has it been buried for a very long time. The carbon atom chains in this oil are likely to be very long. These long chains give the crude oil two properties. They make it dense because long, straight chains of molecules can be packed tightly, resulting in a large mass per unit volume. They also make it difficult for the molecules to flow past one another, making the crude oil more viscous, slower to flow and harder to pump. In addition, many sulfur compounds might be present in these oils. They are called young shallow crudes. Young because they have not had the time to be broken down by the high temperature inside the earth, and shallow because they have not been buried deeply. Typically, young shallow crudes are highly viscous, high density materials with high sulfur content. As the oil is buried more deeply inside the earth's crust, it is exposed to higher temperature. As a result, the molecules can break apart to a greater extent, and some of the molecules containing sulfur will be destroyed. These young deep crudes will have moderate viscosities, densities and sulfur contents. If the oil has not been buried very deeply, it will not experience the same temperature as young deep crude. However, over very long time periods, the same chemical transformation that occur in a short time at high temperatures can also occur at relatively low temperature. Thus, old shallow oil might have the same properties as a young deep one. The analogy with the expression that time is money is very appropriate.
Extraction of petroleum. Petroleum literally means rock oil. It is often called crude oil or black gold. It is a non-renewable source of energy that powers modern life. But what exactly is petroleum? Petroleum or crude oil is a viscous, oily, strong-smelling, inflammable liquid. It is much lighter than water and mainly occurs deep inside the earth, mixed with water, sand, and earth particles. It contains a complex mixture of hundreds of compounds of hydrogen and carbon. Microscopic marine plants and animals, on dying, gradually sink to the bottom of the ocean floor. Here they mix with silt and sand to form a layer of sediment. As time passes, more and more such layers are added. Temperature and pressure combined with anaerobic bacterial decomposition changes the decaying plant and animal matter to a substance called kerogen. Kerogen undergoes further changes to form petroleum. Petroleum and natural gas were trapped within these sedimentary rocks, just like water in a sponge. The component of rock containing the trapped petroleum is called the source rock. Petroleum rises up in the source rock slowly to form a layer till it collects under the non-porous cap rock. This collection of petroleum is called an oil trap. Thus, petroleum occurs along with salt water and pressurized natural gas below the impervious rock layers in the porous rock strata, some 500 to 5,000 meters in the interior of the earth. Oil rigs drill through the rock to pump out oil. The first step is a systematic search for petroleum-bearing areas called oil prospecting. After locating an oil trap and making sure that the site is suitable for drilling, the equipment is transported to the site. An oil rig is set up on top of the determined site to take out crude oil. It is a metallic structure with a platform that houses drilling machinery and pipes for the oil well. A rotary drill bores a hole in the ground or seabed through the impervious rock layers to the oil-bearing rocks and sand. Pipes are laid to reach the oil layer. The crude oil mixed with sand and water gushes out through the pipe due to the pressure of the natural gas formed in the porous layer. As the oil reaches the surface, the dissolved natural gas escapes into the air. These days, natural gas being a precious fuel source is usually pumped away by a pipeline for further use. When the pressure of the natural gas subsides, crude oil is pumped out mechanically with compressed air pumps. The foaming dark-colored crude oil is freed from suspended solids and dissolved gases by means of mechanical separators. The crude oil and natural gas obtained at the oil rig are transported by separate pipelines for further processing and use.
Petroleum utilization. Petroleum utilization is a much more complex process than coal utilization. In particular, the preparation of petroleum before it is sold to the consumer is very extensive. The reason for this is that despite their similar elemental composition, the chemical structure of different crude oils may be very different. Furthermore, a large number of different products are obtained from the petroleum refinery. Most of them are used as fuels. Oil recovery, drilling. After geologists of an oil company have located the general area in which petroleum is thought to occur, a well is drilled. Selecting the site for drilling requires detailed knowledge of the geologic features under the Earth's surface. Pool well would actually produce oil. When a drilling site has been selected, the first job is to rig up or to assemble the drilling rig derrick. This is routinely taken as a sign of activity of the entire oil exploration industry and is periodically reported among the economic indicators. The next step is to begin the actual drilling. In the industry jargon, the well is spudded in. Now moving on to the next topic, we will study the constituents and significance of petroleum. Each crude oil is unique and is a complex mixture of thousands of compounds. Most of the compounds in crude oil are hydrocarbons, organic compounds composed of carbon and hydrogen atoms. Other compounds in crude oil contain not only carbon and hydrogen but also small but important amounts of other hetero elements, most notably sulfur, as well as nitrogen and certain metals. Example, nickel, vanadium, etc. The compounds that make up crude oil range from the smallest and simplest hydrocarbon molecule, 4CH methane, to large, complex molecules containing up to 50 or more carbon atoms, as well hydrogen and hetero elements. The physical and chemical properties of any given hydrocarbon species or molecule depends not only on the number of carbon atoms in the molecule, but also the nature of the chemical bonds between them. Carbon atoms readily bond with one another and with hydrogen and hetero atoms in various ways. Single bonds, double bonds and triple bonds to form different classes of hydrocarbons, paraffins, aromatives and naphthenides are natural constituents of crude oil and are produced in various refining operations as well. The heavier, more dense the crude oil, the higher its C/H ratio. Due to the chemistry of oil refining, the higher the C/H ratio of a crude oil, the more intense and costly the refining processing required to produce given volumes of gasoline and distillate fuels. Paraffin. Paraffin or N-clined with the general formula N to N 2CH plus for N is equal to 1 to 4. These are gases from N is equal to 5 to 15 liquids and above the solids paraffin waxes. The gases methane, ethane, propane and butane form natural gas. Notice the correlations with boiling point temperature. Naphthenes. Naphthenes with the general formula N to NCH form saturated ring compounds in which N is 5, 6 or cyclopentane and cyclohexane are common components of crude oils, often in the methyl form together 2% or more of an average crude oil. In nature, only naphthened rings with 5 or 6 carbons occur because of the range of bond angles that carbon can have. Aromatics. It is generally a minor group of hydrocarbons that contain at least one benzene ring 6,6CH in which all carbons share the fourth bond. They are called undersaturated because they will react to add hydrogen or other elements to their rings. This intriguing group of hydrocarbons usually constitutes less than 1% of most crude oils. Olefin hydrocarbons like aromatics, these are also undersaturated hydrocarbons, but they are much more reactive. N, S and O compounds. These are non-hydrocarbons but are commonly found in crude oil, particularly in the heavier oils and in residue. If they contain at least one benzene ring, they are called aromatic. If they contain at least one cycloparaffin ring, the saturated ring, they are called naphthenic. And if they have neither, they are called paraffinic. Most common, however, are a combination of these. Let's know the characteristic of oil and gas. Petroleum is a fossil fuel. Long before the dinosaurs, oceans covered most of the earth. They were filled with tiny sea animals and plants. As the plants and animals died, they sank to the ocean floor. Sand covered them. Millions of years passed. The weight of the water and heat from the earth turned them into petroleum and natural gas.
So why are fossil fuels such a powerful but ultimately problematic source of energy? Conditions on the waterways of today's Louisiana help us understand how fossil fuels are made and why they're ultimately unsustainable. Oil, coal, and natural gas are made from things, mostly plants, that lived and died long ago. It's taken hundreds of millions of years for nature to create enough of the special conditions that save the carbon and energy in plants to form the fossil fuels that we use. Here's how it works. Plants, like these tiny diatoms encased in silica shells, grow in the upper layers of lakes and oceans, using the sun's energy to turn carbon dioxide and water into more plants. When they die, if they're buried where there's little oxygen to break them down, their chemical bonds retain the energy that began as sunlight. If enough carbon-rich matter is buried deeply enough, for long enough, the Earth's heat and pressure turn it into fossil fuel, concentrating the energy that once fed the growing plants. Vary what goes into Earth's pressure cooker and the temperature, and you end up with the different kinds of fossil fuel. Woody plants make coal. Slimy plants, algae, will give you oil, and both of them give rise to natural gas. The fossil fuels formed over a few 100 million years, and we're burning them over a few 100 years. And if we keep doing that, sooner or later they must run out.
Petroleum is non-renewable. The petroleum we use today was made millions of years ago. It took millions of years to form. We cannot make more in a short time. That's why we call petroleum non-renewable. India does not drill enough oil to meet our needs. We buy more than half the oil we use from other countries. Main products are from oil and gas and their users. Oil and gas are the world's most important energy sources. They produce power for our factories and our homes, run our cars, ships, aircrafts and railways, and provide us with plastic and other synthetic materials that in the modern world we often take for granted. With demand for oil and gas increasing and greater care being taken of our natural resources, the oil industry faces a challenging and exciting future, one that is going to test its ingenuity and expertise to the full. Waxes, resins, asphaltenes. These heavier hydrocarbon compounds have complex polymeric or polycyclic composition, often with NSO incorporated, and radicals that are ends with several free electrons, metallic ions, can attach. This can account for high concentrations of elements such as vanadium gasoline to use as fuel. Untreated gasoline shows in combustion engines a phenomenon called knocking, actually a second delayed explosion. To express this tendency to knock for various gasoline molecules, the first pure hydrocarbon with the greatest resistance to knocking was given a rating of 100, 224 trimethylpanthened or isooctane, and normal heptanes, which cause a considerable knock, was given a 0. Adding an anti-knock chemical 2,5,4-PbCH considerably reduced the knocking, but this is now phased out for environmental reasons. Gasoline for other products. One of the most useful compounds in the gasoline range is benzene, which serves as a basic for products such as insecticides, weed killers, dyes, drugs, aspirins, industrial solvents, plastic nylon fibers, polyurethane foams, rubbers, etc. Benzene can be synthesized from common naphthalene such as hexane and methyl cyclopentene with the help of a platinumed catalyst. Oil supplies about 40% of the nation's energy needs. The most common use of crude oil is kerosene. The next highest group of refining products of petroleum is kerosene, also called kerosene, with molecules ranging from 11C to 13C. It is the first fraction that shows a significant amount of cyclic hydrocarbons, 10 to 40% aromatics, also naphthenes. Kerosene replaced whaled oil for use in lamps. Its production can also be increased by cracking during the refining process. The flash point determines below which temperature oil can be handled safely, that is without its fumes being spontaneously ignited. For kerosene, the flash point is considerably higher than for gasoline. This, together with its relatively low freezing point, is a main reason for its use as airplane fuel. Gas oils. The composition of the oil fraction is complex over its total range of 14C to 25C. Paraffins are less abundant and more in the form of cycloparaffin. Aromatics, mostly polycyclic, as well as non-hydrocarbon compounds, increase compared to kerosene. Light gas oils are used to jet and diesel fuels. Diesel engines are compression ignition engines and work differently from combustion engines. Long chain paraffins that knock badly are very good diesel fuels. Vice versa, branched and cyclic hydrocarbons can be excellent gasoline but form poor diesel fuels. The quality of diesel fuel is referenced to hectane normal hexadecane 1634 CH. Lubricating oils and waxes. These compounds range from about 26C to 40C, although no fixed limits exist. All types of hydrocarbons can occur here, but compared to the lighter fraction, the NSO compounds significantly increase. They give these hydrocarbons their typical dark color. The amount of wax is mostly determined by straight chain paraffins. The pour point is defined as a temperature at which the oil death stops flowing while cooling down. Straight chain paraffins increase the pour point, while branch chain hydrocarbons, cyclic compounds and aromatics lower it. Waxes can be removed with solvents to lower the pour point. Production of gasoline 47%, heating oil and diesel fuel 23%, petrochemical feedstock products derived from petroleum for the manufacturing of chemicals, synthetic rubber and plastic 18%, jet fuel 10%, propane 4% and asphalt 3%. The total is over 100% because there is more than a 5% processing gain from refining. Natural gas supplies about 22% of the nation's energy needs. End users for natural gas in 2005 included electric power generation 26.4%, industrial use 30.3%, residential use 21.6%, commercial use 13.9%, lease and plant fuel consumption 5%, pipeline and distribution 2.6%, and vehicle use 0.1%. Most of the above are self-explanatory except for lease fuel. Natural gas used in well field and lease operations, such as gas used in drilling operation, heaters, dehydrators and field compressors. Plant fuel, natural gas used as a fuel in natural gas processing plants, and pipeline fuel, gas consumed as a fuel in the operation of pipelines, primarily in compressors. Natural gas is considered the cleanest burning fossil fuels, producing mainly carbon dioxide, water, vapor and small amounts of nitrogen oxide. How is oil and gas sent to user? Crude oil is nearly always sent to a refinery for processing. It is conveyed by pipelines, trucks, tankers or barges. Natural gas may be processed to remove impurities at the gas field or at a natural gas processing plant. After processing, natural gas is usually transported by pipelines from producing fields to consumer. However, if natural gas is chilled to about 260 degrees Fahrenheit, it changes into a liquid and can be stored in this form. Known as liquefied natural gas (LNG), it can be loaded onto tankers and shipped overseas. If existing pipeline systems are not available for a proposed oil or gas production facility, new pipelines and associated facilities, example, pump stations or compressor station, must be constructed. In some cases, existing pipeline systems might require upgrading, example, adding additional gathering lines. Terminologies used with respect to oil and gas. These sub-industries are only a few of the moving parts that make up the oil and gas industry. With many industries, oil and gas has a language of its own that investors need to understand before making investment. BBL, barrel of oil, a volume of 42 US gallons, 0.16 M3, CF, cubic feet, a unit measurement for large volumes of natural gas. BTU, British thermal unit, a unit of energy. It can be used to determine the quality of the resource when burned. BOE, barrel of oil equivalent, is a unit of energy based on burning 1 barrel, 42 US gallons of crude oil. The BOE is used by oil and gas companies in their financial statements and a way of combining oil reserves and production into a single measure. Find out how these commodities' fluctuating price affects more than just how much someone pays at the pump. Read How Does Crude Oil Affects Gas Prices? Changing of the rigs. Historically, rig count is modestly correlated with the spot price of the natural gas and oil as measured by the Henry Hub Natural Gas Index and the WTI Crude Oil Index. However, over the past 10 years, as E&P companies have needed to drill more and more wells to maintain flat production rates, the number of rigs demanded has shown a prolonged and steady increase despite the volatility of commodity prices. Investing principles. Key ratios to watch when investing in the land drillers. There are numerous ratios and metrics to watch. Many investors like to listen to the E&P companies' comments about capital budgets and use those details as proxies to determine the current and future part of the cycle the drillers are trading. In addition, when determining a valuation on these companies, most analysts agree that understanding the enterprise value to RIC EV, RIC multiple is significant. Other factors to consider. Other important metrics to keep track of are the average utilization rates of the RICs, the quality of the RICs, horsepower and technological superiority, the average day rates, including how many are contract-based versus non-contract-based, and the rig count for the industry overall. Historically, utilization and day rates are positively correlated as high demand results in high rates and utilization. The land drilling market is a competitive one, but in general it acts rationally. Therefore, by comparing these ratios and metrics across the competitive landscape and determining if one feels comfortable with the state of the industry cycle, and the investor should be able to determine which companies are worth investing in today and for the future. Now, in the end, let us summarize what we have learned in this lecture. The oil and gas industry is made up of many players, each of which has a specific job that spans the spectrum from the discovery of the fossil fuels to the delivery to the end user. Petroleum forms by the breaking down of large molecules of fats, oils and waxes that contributed to the formation of kerosene. The impervious rock covering the reservoir rocks is called a cap rock. Oil trap consists of hydrocarbon fluids held in porous rock covered by a cap rock. The elemental composition of petroleum is much less variable than that of coal, 83 to 87%, carbon 11 to 16%, hydrogen 0 to 4%, oxygen plus nitrogen, and 0.4% sulfur. Some of the best quality crude oils are found in northwestern Pennsylvania, in the vicinity of Bradford, and the term Pennsylvania crude is used as a standard of quality for crude oils. Overseas, oil-deep crudes occur in Morocco.